So let's talk about this. In the data file, I could probably cover up the camera. See if I've got some paper or something. Some opaque tape. Oh, here we go. Perfect.
Okay, and this that you and I were working on the other day, you've already gone through and made another column
I did. I made another column.
that removed the non-functional data.
Yeah, that's really, no, not really data. So let's see. Opening up the data file, and this is what I did with Laurel earlier today. We did it in Excel. It's actually, now that I know it's just a scatter plot, it's actually pretty easy to do in Excel. And you might prefer to do it in Excel. But you've already invested the effort in learning how to do it in R.
Yeah.
So 6 of one, half a dozen of the other. It's not easy to do in either because it's a double scatter plot. So here's the first step. The first thing you have to do is here under CFU milliliters of culture, every place where it's not a number, get rid of it. And what I always do when I'm cleaning data is I save a backup of it. So the way I do it is I have the CFU milliliter of culture, that's the original variable, I don't touch it. I added another column, CFU clean is what I call it. Okay. That way nothing is destroyed. Now to do it in Excel, you take the CFU, well, actually first off to do OD600 is kid stuff, because there's nothing fun, nothing fishy about it. You line up the two columns, like so. And I want to pause here because I don't know how you're going to make this not be identical to somebody else's. If you follow the same steps, you'll get the same result. So I don't know what to recommend. Change the color of the dots or something?
Well, the thing that she was talking about plagiarism whenever I was in lab, was she didn't want us, because while we were in lab, we had to write or draw a hand-drawn graph of the data that we had for our particular table.
Okay.
And she didn't want us to just lay over, all right, and copy everybody. That's what she told my group that would be considered plagiarism.
Can I see the instructions again, please? This is what it says.
It's after she's referring to this graph.
Each person must make their own graphs. Identical graphs, even between lab partners, will be considered a form of plagiarism. And this is under the two computer-generated graphs section.
Okay.
So I don't know how that's, when we're talking about computer-generated graphs, if you use the same algorithm, that you're using the same software, you're going to get the same graph. I don't know how I don't know how you're going to prove it's not plagiarism. If you change the color of the dots, that would do it. I'm going to leave that up to you. I'm going to show you how to do the graphs. Okay. So the first thing is, this is really similar to what we did when we were learning about regression and correlation. It's also really similar to what we did in week 1 when we learned about making double time series graphs. Very similar. The difference is this is not a time series because it's not. Even though they go in over the course of time, it's different groups. And so the dots should not be connected. I'm going to delete the graph that I made. I'll just hide it, actually. I'm going to move away the graph that I made earlier today. Okay. Oh yeah, that's another way that your graphs could all be different. You can give different titles. So to make a time series, or to make a scatter plot with a grouping variable, I first put I sorted by flask, so that flask 1 is this first half of the data set, flask 2 is the second half. Okay, and to do that, you probably remember how to sort already, but just to repeat, I select it all, and you go to Data, and you go to Sort, and you sort. Oh, dang it. And you sort by, in this case I did sort by flask, and then by hour. But it doesn't matter sorting by hour. Okay. Next, I put the two variables together that I want, which is hours after inoculation and CFU clean. It's my variable that I used to clean up the CFU. If you select, including the title, all of that, all the way down to the end of the section, to the end of the flask 1, you're going to have a lot of gaps, and that's going to cause a problem, but that's okay. We'll fix the problem later. Then you go Insert, and you click on the scatter plot, and you choose the scatter plot. Once you've got this created, you're going to right-click on it and go Select Data. Once you're in here, you will add another data series. Now, the first thing you have to, when you click on Add Data Series, is click on the Ys. What's that? Okay. I'm going to choose the Y values, and that is, I'm now going to choose all of the flask 2s, which is everything from here on down. That's flask 2. And I'm taking the empty cells, even though, yes, it's going to cause a problem. It's an easy problem to fix. So that's what I'm going to do. Now I choose the X series. That's the time. That's these guys. And then I'm going to give this one a name. I don't know, flask 1, or this is flask 2. Flask 2. Click OK. Lastly, and this is almost the last step, I'm going to go here to CFU Clean, which I don't like it being called CFU Clean. So I'm going to edit the name, and I'm going to call it flask 1. Then I click OK, and you can see here we've got a double scatter plot with a categorical variable. You can also see that the scale is essentially meaningless after 5, and that's because of all the too numerous to counts and the no datas. So the last thing I need to do to make, well, one of the last things I need to do, I need to click on the scale, the axis, and I'm going to format the axis. I'm going to have it stop someplace reasonable. Now, where do you think it would be a reasonable place to have this stop?
That's 5.
Yeah,
maybe like 7.5 or 8 if you wanted to go beyond, but 5 seems enough.
Yeah, it runs out of goodies around 5. And when I hit Enter, I'll see that it also doesn't have any goodies that are lower than 1. So about 1 hour, between 1 and 5 hours is what we're looking at. And that's your graph. It's not finished because you still need to add in labels. To do that, inside, you click on the graph. So you click anywhere on the graph, and go over to Add Chart Element. I want to add axis labels, and axis titles, and a chart title. That's what I want to add. I'm going to start with a chart title. Put it above the chart, and I'll give it a cool name like CFU-ML. You do this thing. By flask, by whatever. I don't know. I don't want to deal with that. I haven't figured out how to add a legend. I'm going to see if that's an option in here. Yes, it is. Legend. So I want a legend there. And add chart element. I want to add a chart title. Oh, I've got that axis title. I want primary vertical and primary horizontal. So vertical is going to be, this is the CFU milliliter thing. Okay, that's what that is. And then I'm going to add an axis title for the primary horizontal, and that's time. Hours, cents, the jazz. Okay. And that's it. That's a graph. The OD600 one is very similar. It's actually easier to make because it doesn't require you to tinker with the scale. That's how you do it in Excel. Now, let me pause here. Now I'm videoing this, and you'll all have access to the video. So let's just check in. Did that process seem okay?
Yes, but I have one question.
Yes.
How can we get all that data that is on the bottom line up? So that
Can we
way,
change the scale of this so we can actually see a pattern?
Oh, I see what you're saying. Yeah, that is an issue, I think, of outliers. I think these guys are making us unhappy. And so I'm going to try deleting them. Oops, Control Z, that's not what I wanted. I want to delete just that point. So I'm going to see if I can make that happen. Delete series, I don't want to do, how do I delete an individual point? Okay, maybe I can't do that. I can definitely do it in here though. So I'm going to find the outliers and remove them and see if something new happens. It's more, sensible. To do that, maybe I think about this. All right, I think what I'm going to do is just find the maximum value in the data set and remove it. Okay. So 8.12 times 10 to the power of 9. There it is, this one. So I'm removing it, and that makes that look a lot different. And then there's going to be a similar maximum. I guess it's probably this one. There. And so that eliminates those outliers. If you create a graph with removed outliers, you'll need to state in your title you need to make it clear that this is not the full jazz. And I do recommend that you show a complete graph with all the data points just to cover your bases, even if you think it's more appropriate to remove outliers, which I do think. I looked at the OD600 variable, and I looked at the complete data set, and there are outliers that make it hard for me to understand what's really going on. And so I do think it's appropriate to remove them, and I was just working on that. I'll turn my attention to that next. Okay, so did that answer your question?
Yes.
Okay.
Okay. I guess what I was expecting was more of a pattern that, I guess, is it doing that? Because it's...
Not really. Not really.
You know what I mean? The lag log, whatever, it's not really doing it, right?
These are the data, these are what they are, and
Okay.
it's just not really doing that.
But the next thing, did you see the next thing that we're supposed to do?
Is that for CF? Is that for the? Oh, it is for CF.
It's once you take the growth rate, we're supposed to take the graph, right, and pick within the log phase. Where the heck? I mean, it's kind of hard to determine. Is this? I mean.
Yeah, I don't really see that happening with these data. I see
But
it
she'll
with
expect an
OD600.
answer.
Okay.
Okay.
Yeah, I only know so much, but and I'll try to think about that next. I want to first, before we do
Okay.
that, turn my attention to OD600, which to me is a lot more like what I expected to see. I'm not a biologist. I've never seen this kind of data before. I don't really know, but I'm working on it. Yes. And so I created a scatter plot. I was actually just playing with this just now, so there's probably still some bugs I need to clean up. Let me get my syntax. Okay, so yeah, I was just making a no outlier version of the OD variable. Let me just close everything and start over. I'll save. Yes, save. This is my syntax. I'm going to close R and just start all over again. It's just easier that way.
So this is a separate graph, a separate set of information.
Well, it's this.
Or are you
It's
just
the
doing
same
the same
procedure.
exact
Yeah, I
one
could.
in R? Is that what you're doing?
Yeah, I have the same thing in R. I'm going to look at OD600 though.
Okay.
So this is all the syntax I've written. Some of it is useful and some of it is really more of a dead end. So there, I've now just imported the data. That's what that first command says. It says, read into CSV file, and I made it as a CSV, comma separated value. But you can read in Excel also. You give it the name and the path, and you tell it what file to read. And you give it a cool name, like bacteria. And then create a subset and do some other jazz. I'm going to skip this because I believe it was a dead end. I'm going to instead turn my attention here to this function called XY plot that I just found out about, which is very powerful. So I'm going to first make the OD, make a subset called OD. This tells it to load a package we need. This tells it what colors and symbols I want to use for my graph. This opens up a new window, and this creates the XY scatter plot. And I used as the symbols 1 and 2. I didn't think anything could be more obvious than that. You want to know which flask you're looking at, you look at the symbol. It says 1, it's flask 1. But if you don't like that, you can make asterisks or X's or whatever other shape you like. I made the 1s red and the 2s blue. Okay, I did that, and then put a title. Oops, the stack is all broken. Close, and start again. I don't understand this part, but it should work if I run it all at once, which is what I'll do. So you select all the syntax you want to run. What this says is create an XY plot. Your outcome variable is OD600. The x-axis is going to be hours. Separate by groups. Here are my x-axis and y-axis labels. Use the colors I told you about, which are red and blue. And the symbols I told you about, which are just the numbers 1 and 2. Give it a title, give it a legend. And that's what this all says, except it's not working. Like I said, there's still some bugs because I'm trying to figure it out myself. It's pretty irritating. Plot.now. Okay, let's try that. Try it now. Okay, now it works. So this creates a graph with the full data set, which I think is very noisy. It's got a 21-hour data point for each flask. And it, of course, being 21 hours, it looks very different from everything else. It's also got this outlier in 2, which I don't understand. I mean, I simply don't know what that means. So I'm going to get, I was just working on, right before you got in, a version of the data set that eliminates that. I'm calling it od.noOutliers. And I think this is what's causing my grief. I'm going to hide that. So basically this is the same plot removing those extreme values. And there it is. You can see it's a much cleaner graph. I'm going to move the legend over to the top left instead of top right. Okay. And you just submit the syntax you want. And there it is. So now it tells a much cleaner story.
Yes.
Yeah, and so this is what I was expecting. This is what I know about. I don't know very much about bacterial growth, but I know it does this. I know it's exponential growth function. Actually, it's logistic. It goes up, levels off.
And from that, it's very easy to pick the log phase of what we're looking for, but the log phase that she wants us to pull off of is the CFL.
Okay.
CFU per milliliter, right?
Okay. Yeah, that's what it was. And so I'm not seeing how that can be done, but I was just about to create the graph for that.
Since it can't be done, she can get like an effort and try to do it with the information from the another graph. At least you made an effort to try to make something. Same, I realize this as well. Because I don't understand any, there's not enough pattern in the other one.
I just see it going up and then back down. I don't get it. You know?
Well, it is supposed to go back down. Because
So, but you.
they're supposed to go like, it's supposed to go like this. It's supposed to go like this, like this, like this. And then you might get a blip and then off.
Right.
But at the time that we pulled it,
it should be in here.
That's right.
Yes.
That's right. It's supposed to be in the growth phase. What's your word for growth phase? What do you call it?
Log.
Log. Well,
It starts out at lag, log, then it goes stationary, and then indefinite.
To decline, yeah.
oh, okay, that makes sense. Sure.
But we should have been at least 6 hours away from, or right there at the beginning of stationary by the time we ended the lab. Because the first group should have had probably the lag and then the beginning of log phase, if not all the way up to stationary.
Okay.
We should have been picked up probably somewhere at the beginning of log phase and then up to stationary.
Okay. Well, okay.
I believe.
The
But
data don't look like that. Can I see the instructions for the next step?
the next step is for us to do a calculation.
You know
Okay,
what, I'm
that's
at a
right.
point, where I'm at a point, this is worth 20 points, and we have a lab practicum tomorrow. Do I want to spend hours making this work for myself, or do I want to spend the time on the practicum tomorrow? That's my toss-up right now. It sounds like a lot of time by the time I go through the video, figure out each step one by one between the video and my computer screen.
Yeah. I'm going to be up late tonight anyhow.
You know, if we plotted this on a logarithmic scale, we might get a more obvious pattern. I'm going to give that a shot. I don't think I should be videoing this because I'm now poking in the dark, but okay. Oh no, I could do a transformation. I can do a transformation on it. Let's see, if I transform the outcome into log. Let's try that. Okay, let me try that. It might be more obvious if I do that. So, make a new variable. We'll call it CFU log. Does she say what base to use for the log? Natural log, probably? Okay, so let's try that. Nope. Clear. Come on, Keiko. Alien function. Yeah, I did it right. Oh, I see the problem. Alien. Okay. Nope. Cannot find the function ln. Well, okay. It says it exists. Let's try log. Just any log would work. Any logarithm would make it more self-evident. So that's log 10 that we're working with. I'm going to try graphing that. See if that looks better. I don't even know what happened. See if you log by hours, grouped by flask. Hang on a second, maybe my computation was wrong. If you log. No, it looks correct. Well, I don't know. I mean, the graph I'm seeing doesn't look linear. So, do we just pick two? Or do you just pick 2 points and go to town with that? Pick a higher value from within the log phase. That'll be your xt. Pick a lower value. That's your x0. Find the time. Oh, this is just rise over run. And you take the logs. This is the slope of a regression line, isn't it? Yes. Well, actually the next steps after this don't look too difficult.
We just have to pick
Yeah, and
a high one and a low one.
Yeah.
With the scatter plot.
that's not, yeah, I mean, that's right. That's fine. None of that seems to be the trouble. This is the trouble. I don't see. You know, maybe that's a high one. This value up here, it's high. And then, like, here's a low one. I think that could work.
It's the function of the outlier.
Well, but we know what to expect with exponential growth, is that should be the standard, not the outlier, right? Like, that's what it should be doing. It should be going just like that. So, I don't know. All I can really tell you is how to graph the data.
Yeah.
That's how you graph the data. As far as what I think it means, I think that if it were me, I would pick that probably as the point and that as another point or something. You know, just pick any 2 points and go to town with it. Okay. You have questions about how to make the graph?
No. I just need to change mine over from a line graph, time series graph, to a scatter plot graph.
Yeah, and I'll send you the syntax in R, so you can, and you can tweak that and play with it any way you like. If you don't like the 1-2 symbol, for example, you just change the symbol.
Yeah.
It's not difficult.
Yeah, after we met last time, I found a syntax online that I was trying to get to work, but I don't have the knowledge that you have as far as actually knowing what I'm doing, what each piece means.
Yeah.
I mean, I figured out this tells it what color, this tells it this, and this puts a label on it, and I can move the legend around inside. But it's like with the syntax that you did send me, whenever I loaded it into R, into the R script, it didn't want to go to that file and pull it. I had to go back in, clear out R, reload it, go and import the data, and then pull it, let the syntax pull it from what I imported.
Yeah, there's a reason for that. The path in my syntax tells it to go to my computer. So this command up here, I'm using the function read.csv, and it tells it to go on my computer. That's where I have this file saved. So you'd have to change the path.
Oh, I wound up doing that, but
Okay.
I had to, because this laptop here is kind of a pain in the butt.
Yeah.
After I imported it,
Mm-hmm.
it told me what the path was, so I just cut and pasted that into it. That thing's dying right now.
Oh, okay.
Or no,
I see.
that was.
Yeah, that's actually that's how I do it too. That's hacking.
That's what?
That's hacking. That's what hacking is. That's how bad coders. I'm not a good coder. That's how bad coders work. Is they just they'll cheat. They go steal some other code that they used before. Anyway, I'm gonna stop this. I think.